let's graph this function y equals 3 pi over 2x plus 1. And I'm going to start out by graphing my parent function, like I generally like to do, of y equals sine x. So I know that the period of my parent function is 2 pi. That's how long it takes to complete a complete cycle of the sine function. And so I know I can mark this point on my axis here as 0. And I'm going to mark this point on my axis right over here as 2 pi. So if that's 0 and that's 2 pi, right in the middle here is pi. And right over here is 3 pi over 2. And right over here is pi over 2. And I think to help me out with values here, I'll sketch a little unit circle. You know, I like my unit circles. Whoops, that's an ugly looking circle. I just erased it and replaced it with a better looking circle. So there's a circle. I'm gonna put an x-axis. Sorry, it's hard to do this with the pens, but we'll get it across. And a y-axis. So I know that this point over here in my circle is my 0, 2 pi angle. This is my pi over 2 angle. This is my pi angle. And this is my 3 pi over 2 angle. And just while I'm at it, I think I'll put in my coordinate points. So this right here has 1, 0. This is 0, 1. This is -1, 0. Whoops, that's a parentheses. And this is 0, -1. -1. That is the ugliest looking -1 that I've ever seen. Let's see if we can't fix that -1 right there. Try again. 0, -1. Much better. And we remember that the x values are my cosine values and the y values are my sine values. So, as I go around the unit circle, at angle 0, you kind of see 0, pi over 2, pi, 3 pi over 2, 2 pi. Coordinates with the line. I basically cut my circle and I stretched it out. 0, pi over 2, pi, 3 pi over 2, 2 pi. So at 0, sine is equal to 0. So I plot that point right there. And at pi over 2, my sine is equal to 1. Well, I'm going to make this right here my line for 1, and then I'll correspond with that down here. I'll make this my line for -1. So at pi over 2, my sine is 1. At pi, my sine is back to 0. At 3 pi over 2, my sine is -1. And back to 2 pi, my sine again is 0. Well, those are my 5 key points. I've divided my period from 0 to 2 pi into 4 segments by using 5 key points. 1, 2, 3, 4, 5 key points. And now I'm going to make a real strong effort to connect these. Please forgive how ugly it's going to look. Well, that's not too bad. There we go. Going down now. Oh, this is actually pretty nice. There is my sine function, all nicely graphed. So now if I'm transforming this, my transformations at this stage take the form of y equals a sine omega x plus k. My A stands for my amplitude. and that is right here. My amplitude is 3, which means that my sine function, instead of going as high as 1 and as low as -1, will go as high as 3 and -3. But rather than redrawing the graph, I can just change my axis. So I'm going to take my eraser here. I'm going to erase my 1, and I'm going to erase my -1. And I'm going to change my axis, and I'm going to have it say that I want this spot to be 3 and this spot to be -3. So now the amplitude of my sine graph, the amount that it goes up and down, it's now actually going up 3, and then it's going down 3, just by changing my graph, my axes on my graph. Now, the next thing I need to be concerned about is the period of my graph, because as I explained in a prior video, the omega here is what's going to change the period. And the way that I figure out how much my omega is going to change the period is I take the period of the parent sine function, which is 2 pi, and divide it by my omega, which, as you can see, is pi over 2 right here. That's my omega. So I'm going to divide my 2 pi by pi over 2. So to do that, I will multiply the top and the bottom by the reciprocal of my denominator, that is 2 over pi. This cancels out and becomes 1. So now I have 2 pi times 2 over pi. So let's just write it here, 2 pi, and I'll put it over 1 so you can see the fraction, times 2 over pi. Well, as you can see, my pi's are going to cancel out, and I'm going to be left with an answer of 4. So the period of my function here, of my transformed function, is 4. That means from the beginning of the cycle to the end of the cycle, instead of it being a distance of 2 pi, it is a distance of 4. So I'm going to make this a 4. And what I'm going to do is I'm going to then figure out, well, if that's a 4, then right between the 0 and the 4 is 2. That's smack dab in the middle. Between the 2 and the 4 is 3. And between the 2 and the 0 is 1. So these points are effectively gone on my x-axis, having been replaced now by these green points. So my graph has been transformed for my a, for my omega, and all I'm left with is my k. And as you recall from our transformations of all other functions, the k is the vertical shift. So this graph is going to shift up 1. Well, I could redraw it, remark all my points here, 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 and here, or I could do something different. And I can change my center line, which in my parent and in my initial transformations is the x-axis. I'm going to change my center line from being 0, y equals 0, to being y equals 1. Well, if I do that, this 3 now becomes a 4, and this -3 now becomes a -2, and my graph has been completely transformed. I guess if I wanted to be nice, I could kind of sketch in what the x-axis looks like. That would be my that would be my x-axis right there. So you can kind of see how the graph has been raised. But that's how I do this particular transformation. So just so we can see it a little bit more clearly, I'm going to go over to a page here where we're going to have the smartboard show the graph. And this is right here, just the graph of y equals sine x. Now the numbers, they don't give me pi numbers, but you can kind of see I start here at 0, and I go up as high as 1, and then I come down back to 0. That's at pi, a little bit past 3, so 3.14. and then I go down, and I come back up, and in the space of 2 pi, which would be about 6.28, which looks like right about there, I have completed one cycle. And my amplitude of the sine function, since there is no a, is 1. So it's going up as high as 1 and as low as 1. And that just keeps repeating on and on and on. Now here is the graph of 3 sine pi over 2x. I'm leaving out the k for just a minute, just again so you can kind of see what the graph looks like. So you can see now in the purple here, I start at 0, I go up as high as 3, and that is at point 1. I come down back to 0 at point 2, I go down at 3, and I come back up completing my cycle at 4. So I've completed my cycle. My period here is 4. It's no longer the full 2 pi. My period is 4, and I've got a much larger amplitude. Now, when I take this graph here, and I'm going to add 1 to it, plus 1, we'll see the graph. See, it just shifted up. My new center line is, let's make it, we can do this. My new center line is right here. You can see how that cuts my transform function right in half. And it went up 1, so everything raised up 1. My amplitude is still 3, but it's going from 4 to negative 2. So the total range from minimum to maximum is still 6. So my amplitude is that divided by 2, which is 3.